What is the most beautiful part of the ocean? Is it the sheer vastness of the ocean blue? The spectacles of bioluminescence that adorn the darkness of the deep? Or could it be the coral reefs with their infatuating display of colors? This is the story of how coral reefs are born and how we are killing these living artistic masterpieces. This is the story of Corsola, the coral Pokémon. Corals are a colonial species consisting of organisms called polyps that reproduce asexually. As such, corals are many organisms bound together in a group. For example, in coral reefs, which is what I'll be referring to whenever I talk about corals in this episode. As a result, Corsola with its branches of polyps are a group of animals living together with the same DNA. According to the Pokédex, Corsola's branches glitter very beautifully in 7 colors when they catch sunlight. They are so stunning that people have prized the very tip of Corsola's head for its marked beauty. Meanwhile, Pokemon like Marini and Toxapex eat their branches. Thankfully, Corsola have evolved to be able to shed their branches and recover them in a matter of days. Corsola live in warm, unpolluted, southerly waters where they provide habitation for small Pokemon. Some settlements have been established over groups of Corsola. Unfortunately, due to human activity, the ocean is becoming warmer and more polluted. This is equivalent to habitat destruction, and the result is a phenomenon known as coral bleaching, where Corsola die and become white. The effect was first documented in the Galar region. This is why Corsola that have become bleached are known as Galarian Corsola. To avenge their death, they curse anyone who touches them. Galarian Corsola prey on the souls of people and Pokemon indiscriminately. The result of this is the exposure of their true and final form, Corsola. Despite their uncanny ability to regenerate, why are these creatures that have been thriving since before the nativity of humanity suddenly starting to die, purging the ocean of its enchanting beauty? What causes coral bleaching? Where do Corsola come from? How are corals born? Coral-like reef builders have been existing for hundreds of millions of years, but it was only in the last 200 million years that modern corals evolved. When corals reproduce sexually, they miraculously release all their eggs and sperm into the water at once. This cloudy ejection is known as spawning. When an egg cell is successfully fertilized by a sperm cell, it becomes a larva. This larva will seamlessly, aimlessly drift in ocean currents for days, weeks, even months. The larva will continue to drift until it detects a suitable rock or another coral that's already existing and permanently lock itself to that structure. Next, the larva metamorphoses into a polyp. A polyp is a soft-bodied animal that can range from millimeters to centimeters in length and secretes an exoskeleton from its base to protect the coral. The polyp has a multiple of 6 tentacles which are used to stun zooplankton and pull them in to their stomachs where they are digested. Any undigested material is expelled back out of the mouth. Meanwhile, photosynthesizing algae known as zooxanthellae will gather into the polyps to form a symbiotic relationship that has been established over evolutionary time. The polyps are colorless, but with these algae, they introduce their unique colors. Alternatively, the algae may already be in the polyp from birth. The zooxanthellae provide the polyp with as much as 90% of their energy requirements, as well as nutrients such as amino acids. At the same time, the polyp provides the zooxanthellae with easy access to sunlight, food in the form of waste products such as carbon dioxide, and protection from predators. This delicate balance depends on the initial conditions, i.e., why the larva chose this specific position in the first place, being maintained. Graciously, the ocean is a huge heat sink. Water has a high specific heat capacity, meaning that it can absorb a lot of heat without changing its temperature by that much. Enter humans. Thanks to the Industrial Revolution and global warming, the oceans have absorbed so much heat and carbon dioxide that the polyps have become heat stressed, to the point that they dispel the zooxanthellae in their bodies just to get a better chance of survival. Unfortunately, the ocean can't just rewarm itself, so the polyps never regain the algae that made them so sightly in the first place. As I said, polyps are colorless, so the reason why bleached coral is white is because the exoskeleton is made of calcium carbonate, which is white. Of course, not all corals are the same, but a lot of them live near the surface where the effects of human activity are most pronounced. And if that wasn't enough, the carbon dioxide from burning fossil fuels reacts with the water to produce an acid that dissolves the exoskeleton. Oh, I'm not done. I have mentioned the fact that corals are a keystone species, meaning they maintain the welfare of an entire ecosystem of thousands of fish and different animals. When the corals die, these small animals lose their shelter from large predators and their safe haven to nurse their defenseless offspring. As a result, biodiversity in the area decreases. When a coral reef thrives, even tropical waters that are normally low in nutrients become productive because corals get most of their energy from the sun and can effectively feed the entire ecosystem. It is incredible to think that structures that account for only 1% of the entire ocean floor accommodate and sustain 25% of all marine life. The spectacular and well-known Great Barrier Reef, for instance, has been growing for millions of years and is among the most biodiverse habitats throughout the world. If, due to coral bleaching, the reef disappeared, the consequences would be profound. Exotic species will be driven to extinction. Complex food chains will collapse. Coastal regions will become more vulnerable to storms and erosion. A thriving ecosystem will be lost in a decade, never to be recovered. Corsola will share the same fate as the corals. Let's not get needlessly pessimistic. Notice how Corsola are fundamentally different from other corals in that they are mobile. So when the waters become unsuitable, they can easily find a better location. Reefs still exist, but Corsola have exploded in number because of how adaptable they are. They contain a high density of photosynthesizing zooxanthellae on the tops and sides of their bodies. The underside do not receive much sunlight, hence you can see exposed the calcium carbonate exoskeletons. Their branches can regenerate in days. Concealed inside them are the polyps, but they are almost never seen because they get almost all of their energy from the photosynthesizing algae that make up a third of their bodies. Moreover, they can also receive food through the mouth at the front of their bodies. I don't understand. Why do Galarian Corsola exist then? You underestimate the combined impact of billions of humans releasing greenhouse gases for centuries. The ocean has masked our impact for too long, and we are finally seeing the consequences of our actions. Remember that Corsola live in water, This is their natural habitat. However, due to the acidification of the oceans, Corsola evolved to become more mobile, unlike coral reefs. Unfortunately, too many southerly aquatic regions are becoming too polluted, too warm, and too acidic. This change has happened too quickly for Corsola to adapt well, making them lose their zooxanthellae as a stress response. Corsola have also been posed that their branches are prized due to their ability to sparkle brilliantly in direct sunlight. They can somehow regrow their branches though. Corsola reproduce asexually to regrow the polyps that form its many branches. Of course, to replace their polyps and reform their exoskeleton, they require a lot of energy. Certain peoples have built homes over Corsola populations, blocking their access to their main source of energy. I'll discuss this further later, but this has resulted in a steady decline in the male population, which typically has less zooxanthellae since the dawn of humanity. Did you know the same acid from carbon dioxide dissolving away the exoskeletons of coral reefs is in every fizzy drink you've ever opened? Wait, there's pollution in fizzy drinks? No wonder. Carbon dioxide isn't pollution. It's part of the composition of the air we breathe. Carbon dioxide is a greenhouse gas, which means it traps heat from the sun once it reaches the earth. Oh, wait. Isn't that a good thing then? Carbon dioxide is stopping heat from entering the earth. It's not that simple. Light is a wave, and it has a wavelength. When light reaches the earth's surface, the light that is reflected changes its wavelength. Oh, so the reflected wavelength is the one absorbed by the greenhouse gases. Yes, that is. So why isn't it the atmosphere that gets hot? I thought carbon dioxide was way above us. What am I missing? Well, if you stopped interrupting me, you would... Am I not trying to learn? Okay, if you interrupt me again... So the energy is obviously radiated back down to the surface. Oh, did you finish? Oh, why is there even acid in fizzy drinks? You have it backwards. Carbon dioxide is added to drinks to make them fizzy. Now, carbon dioxide reacts with water to form carbonic acid. However, this acid is weak and unstable, and it can easily decompose to form carbon dioxide and water. Is that what the fizzing is when you open a can? But why does it have to fizz? Excellent! Every can stores its contents under high pressure. Opening the can lowers the pressure inside, causing carbonic acid to break down more rapidly. Carbon dioxide then escapes through microscopic gaps as the seal opens, creating the characteristic hiss. Your second question? Why does it have to fizz? To preserve flavor, shelf life, and tanginess. I should point out that some companies add slightly stronger acids like citric acid to make the taste as exciting and alive as possible. When acid touches the taste buds, it activates pain receptors. No pain, no gain, right, Professor? He's going to the gym, isn't he? Many tribes have built settlements on top of coastal colonies. Historians speculate that this is because Corsola have no other option but to come out of the water to receive sunlight, which exposes the splendorous glint of their branches. In such tribes, the whole Corsola colony will come out every morning at the break of dawn to receive sunlight. This fills the entire settlement with scintillations of color. Some of these tribes worship the Corsola as gods of color for this reason and will sacrifice animals to them. This causes the number of Corsola in such areas to decrease, as the increase in population density of Corsola triggers an infestation of Marini and Toxapex in that region. This is why some of those settlements have been abandoned. Corsola is not a plant, nor a stone, nor a reef. It is a moving colony, a constellation of genetically identical polyps, armored with calcium carbonate as an exoskeleton and powered by the sun. Since records began, Corsola have been turning light into stone. But when the oceans change faster than evolution can follow, even living rainbows are reduced to ghosts. Even as humans pollute the oceans, one Pokemon is quietly making things worse.